Hello and welcome to this Android tutorial. In this tutorial, we'll be exploring about Android activity lifecycle. So let's get started. Develop efficient, scalable apps with enthusiastic ideas. Start your journey and take your dreams to reality. Each activity has its own lifecycle and it passes through different states of its lifecycle states. This passing through lifecycle state generally depends on the user action. Let's see what's Android activity lifecycle. This is the Android activity lifecycle. I will explain each and every state of an activity. First, whenever we launch an activity, the Android OS creates instance of that activity, and whenever it creates the activity instance, the onCreate method is called. So whenever the activity instance is created, the onCreate method is called, and so it's the best place to set our view. So we set the view, we set content view over here. So after we set the view, the onStop method is called. In the onStop method, this method is called after onCreate and the view is ready to be shown. And after that, AonResume is called. AonResume is the activity states where the UI is available to the user and the user can interact with the UI. Main difference between onStart and AonResume is, in the onStart, the view is only ready to be shown, and in OnResume, the view is shown to the user and user can interact with it, and all the user events can be accepted. After OnResume, the activity is in the running state. So whenever the another activity comes into the foreground, first of all the onPause method is called, showing the indication that this activity will be closed. In this lifecycle state, the UI will be shown, but the user cannot interact with it. From this, again, if the user returns to the activity, if the user decides again to go to the activity, then OnResume will be called. So if the user does not return, then onStop will be called. Then the activity is no longer visible to the user. From here, whenever the user navigates back, the onRestart method will be called, and then the onStart method will be called. So again, the lifecycle state goes as you have seen. So you can remember that there are two cycles. From whenever the user returns from the onPause, the user will return to the onResume, and whenever the user returns from the onStop, the user will return to onRestart and onStart. So onRestart is just an add-on that is called before the onStart, and this is not called whenever the activity is created first time or whenever the activity is shown first time. So now we are in the onStop state. Here's higher priority that your Android OS can kill your app, but that's not often. Your app is not resource heavy, your app will be not destroyed, so you don't have to worry about that. So mainly you should handle the higher consuming resources in onStart and onStop. You should not put heavy work on the onPause, so I will explain it later. If the activity is killed by the OS, then again onCreate will be called. So after the onStop, the onDestroy method is called, so that the activity is finishing or being destroyed by the system. So this is how an Android activity lifecycle is. It's very important and it's very crucial to know that this activity lifecycle states, because this is where you will be managing most of your app's performance. So as per the methods, the activity have their own state. So after the onCreate method, the activity is in the created state. After the onStart method, it is in the started state. After the onResume method, it is in the resume state. After the onPause method, it is in the pause state. After the onStop method, it will be in the stop state. And similarly, after the destroy method, it will be in a destroyed state. See it in practical. So we'll be experimenting each and every lifecycle state of an activity, so that we make a perfect route on this activity lifecycle. So for taking a deep dive into activity lifecycle, we just create a new project, take an empty activity, then we'll name it activity lifecycle. Just press enter. So now that Android Studio have generated our project, we'll show it. So this is one of the lifecycle method, that's onCreate. So we'll similarly override all the lifecycle methods. After the onCreate method, the onStart method is called. Then after the onStart method, the onResume method is called. So we'll override the onResume method, and after the onResume method, the activity is up and running. So after that, whenever the user is in the way of exiting app, the onPause method is called. Then after the onPause method, the onStop method is called, in which the UI is not visible. And after the onStop, when the app is totally destroyed, the onDestroy method is called. Okay, these are the lifecycle callbacks. So for looking forward how they are called, we will use the Android logging. So we just build a tag for that first of all to identify it. So just main activity. Okay, now just we'll prepare for the logs. So in the onCreate method, we will print here onCreate, which will Android Studio will generate it automatically for you. So whenever the activity is in such lifecycle states, these logs will be printed. So to filter out these logs, we'll go to the log tag. Then so we'll just write in our tag over here. So only our tag is shown. No extra stuff is shown. Okay, now let's run our app. So you can see that first of all onCreate is called when the activity is created, then the onStart, and then the onResume is called. So now when we press the back button, first of all onPause is called, then onStop is called, and then onDestroy. So to briefly understand it, I will just simulate and delay over here with the thread.sleep. So delay of 500 milliseconds. This is a very bad practice. Just for explaining purpose, I am doing this. Okay, after each state, it will pause for 500 milliseconds. You will see a side effect too of this. So just I will restart the app. Okay, you can see onCreate, onStart, onResume, and you can also see this log. So it's a very bad practice to perform a long task on onResume and onPause. That is why I said it. So you can see that there's an Android log. It is due to the activity thread was blocked. That is the user interaction or the UI will be freezed in this 2152 milliseconds. That's for 2 seconds. That's a very high cost you are giving. So in the onResume and onPause, that's a very bad idea to perform a long heavy task. So to know that why is it so, we'll create another activity and fire it, and I will show you that what happens actually when another activity comes in foreground. So first of all, we'll again see the onPause, onStop, and onDestroy lifecycle callbacks. You can see they're working fine. So to simulate that, I will remove this simulated delay. Now I will just create another activity. So now that I have created the another activity, I will similarly override all the lifecycle callbacks. So you can just copy and paste this. So this is activity 2, and you can reuse the layouts, hierarchy of view. First of all, we will need a button to fire this another activity. Instead of hello world over here, I'll just change it to button. Then launch activity 2. Okay, now we'll just get the reference of the button. Launch activity 2 be with the find view by ID. We did not specify the ID, so ID will be launch activity 2. Okay, this will be the ID. launch activity 2. Okay, once we get the reference of the button, we can add an on-click listener to that, import it, launch activity 2 dot set on-click listener. So whenever the button is clicked, this callback will be called. What we want to do is, we want to fire another activity up in the foreground, activity 2 be an intent. So activity 2 will be an intent, import it. The explicit intents needs two type of arguments. You can see about intent in detail in the above card linked video. So we'll pass in just the name of the another activity. That's activity 2. Okay, we'll just start in activity 2. Okay, after we have configured the button, we will make the tag same. Instead of main activity, we'll name it activity 1 LC Lifecycle, activity 1 Lifecycle. So similarly here, activity 2 Lifecycle. So we can observe the logs. So we'll just bring up the log cat. Over here we'll type in activity because it's the same between these two, and just hit on the play button. So on create, on start and on resume is called. So whenever we launch the second activity, you can see now what happened. So first activity is on pause is called, then the on create, on start and on resume is called of the second activity. After it's in the resume state, then the activity once on stop is called. So for better understanding, pause the video and understand this. So on create, on start and on resume was called when we created the first activity was launched. Then when we launched the second activity, the first activity is on pause was called, then second activity goes through a life cycle that's visible to the user and user can interact, that's the on resume state, and then the on stop was called of the first activity. The activity cannot jump directly to the other life cycle state skipping some, it has to go through all life cycle states. Now just observe that first activity is on pause was called and the second activity is on resume was called. So that is why we should avoid the CPU intensive task in the on pause method, because how the Android is running, it's basically single threaded for the UI, that's not multi-threaded for the UI. So whenever you will override this on pause, and if you do more CPU intensive task in the on pause, your app will definitely crash if it's more, or your app will freeze if it's even a small amount of work. So you just avoid the on pause method intensive task. You should do it in on start and on stop, because you can see that on start is called between the life cycle state and on stop is called after the second activity is displayed. So user will not experience such a lag. But if very intensive, you should use the background threading. I will be having a video on background threading, or the services if it's a very long task. I'll be also explaining about services, job schedulers, etc. all the modern. Okay, now that we are understood that in the on pause we should not perform some CPU intensive task. So now let's see more about this. Just observe, when we press the back button, the on destroy is called. Now just observe what happens when we press the home button. So first of all, when we launch the app, on create, on start, on resume is called. Then when we press the home button, you can just see that on pause and on stop is called. The on destroy is not called. So when we again open the app, from the on start and on resume is called. We'll also see the on restart method. Okay, again we'll launch the app. First of all, on create, on start, on resume. Then we click the back button, on pause, on stop and on destroy is called. So first time the on restart is not called, as I said. So again we will launch our app. Now we'll press the home button, so it only goes until the on stop method. it doesn't destroy the activity. Okay, the onStop, and again when we open, you can see that onRestart, onStart and onResume is called. So onRestart is called before onStart. Please subscribe the channel if you want more such videos and press the like button if you like the video.